Welcome to a new test and teardown video. This time it's another one of those DIY projects from DMI. And this one is a very big and heavy power supply. It's called ionlab buffer power supply model 2. We only got 2 switches and 2 indicators on the front. Mains, power supply input, and a converter on the converter. I want to show you the rear side first. Here is the rear side. Mains input, and that one is very good explained by the text. We also know what kind of power levels to expect and all that kind of stuff. And then we got some 3055s, voltage regulators. We got a 50 Hertz sync signal, and I don't know if this is input, output, sine wave, square wave, or how much. So that is a little note to remember for the future when you design all sorts of cool things. Please put a little note about, is stuff inputs, outputs, and what is the waveform, and what kind of levels to expect and what not. I mean, it's not that easy to figure out for stupid guys like me who don't know this product. So, of course, this is an output, 220 volts AC output from this converter, but it does not say. It does not say its output and how many watts and how many amps and stuff. So that is a little bit of a problem. We also got here some other connections. 23 volts regulator 3. That is a battery, so that's probably an input. And we also got supply voltages. What is that? And supply and sink. Again, that's the same connector, so that means you can probably connect stuff here. Right or wrong, right? You need to do it right. And then we've got 13.7 volts DC buffer and a 14.4 volt regulator 1. So let's look inside and see if we can figure this out. So here is what I thought about this. Mains entry. We got a filter, and mains entry goes through the switch and to the first transformer. So far so good. We got some 2 hefty diodes, filters, and a capacitor. So that makes this DC unregulated DC, right? Remember the 2 big transistors here. So that's 1. And then this output goes to the collector of that one. And then we got a little regulator board here. So that's probably connected to one of those outputs here, right? And then we got some diodes, probably reverse voltage protection or some battery charge discharge protection, stuff like that. More regulators. So we got 3 voltage regulators, more or less the same circuit. And it even says here, I don't know if we can see this. Let's go real close here and see. So that we got an op amp and some resistors and some filters and stuff like that. And it says voltage current. So we got some different pot meters. You can either mount one or the other one, depending if it's voltage or current you want to adjust. So this is probably just a standard little voltage regulator board used for all sorts of projects, but in this case only voltage is used and current is not used for this. But here comes the interesting. Let me try to swap this around so it's easier to see what's going on here. So that is the converter on off, but look at that one. Here is a power amplifier board. I can't really read what it says here, so I'm going to see if I can figure that out. But we got this piece of aluminium, and we got power transistors, 4 of them. So I think this is a driver, and then the power transistors like that. And that is of course the low voltage side of this transformer. And there's a center point of the 2 windings, and then it's a half bridge push-pull primary side. And look at that. Here we go for 12.5 and 0, so that is how it is. And then we got mains output on the other side. So what we got here is actually like a UPS power supply. So it's taking mains voltage from the other one, making it into DC charging batteries and all that stuff, and then batteries go back in and is regenerating mains supply. So that is what we see here. So that's probably input from the batteries going through some filters, capacitors, and then we are running off that. And then the mains voltage again is also filtered, and then it goes out on the blue bananas here. So I got high expectations. I should be able to power this up and get it up and running. That could be really interesting. So that is, I think that is what this sink here is doing, right? So you can probably switch it into external synchronization, or so you can make this accurate. But I don't know if this is running only on that. See, this is the green sink input. Yes, that is the signal that goes down to that connector, and then it goes in here, right? So I think this is only a power amplifier. There's no oscillators or anything here, so that means it's not working without this input. So how much do I need to put in? Is it sine wave or square wave or whatnot? So that is interesting to figure out. But I think I'm gonna play with the charger first and see if I can get that one up and running. So this is going to be my first power up of the mains part, and I'm measuring on the 2 outputs to the right first. I just put in 2 voltmeters, and then I'm going to turn it on here, and I'll just crank up mains voltage. Oh, we see some. So that is 60 volts of mains. I can easily crank this up because I can see there's no power usage. Look at that, nicely regulated. So that is 220 volts of input, and my power consumption is 4 watts. So this one is humming a little bit. So that means, yeah, we got definitely output voltage on the 2 first. Okay, so far we got the 26 volts on this capacitor, and we got 14.5 and 14.2 out of those 2 banana sets here, and we got 0 volts on those. So that's probably inputs. Well, and that is probably the 50 hertz input as well before we can get the converter up and running. So now I'm trying with the converter. What I figured out is the 2 voltages with the same value. I connected those together, right? And then when I turn on and off the converter, I get the 14.5 volts on that capacitor on and off together with that switch. So it has to be right. And then I connected my voltmeter in AC to the output of the converter. And then my 50 hertz, which I assume is input, is now connected to a signal generator. set for 50 Hertz, and now I'll just slowly crank up the input 50 Hertz signal. So when I turn on the converter, I don't see anything happening, right? Okay, so let's proceed. We don't see anything, right? That is... Oi, oi, oi! Oi, 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 oi! Did you hear that? Holy crap and cannoli, I got super scared. Only 1.4 volts? Ooh. There's definitely some stuff is going on here. I better get a scope on because this is scary. Because I can really hear some funny sounds, and it does not sound like this is supposed to sound like that. Oi, oi, oi! I better get a scope on here. Okay, so I'm measuring. Ground is of course the ground input, and the both sides of this half bridge push-pull. This is where I'm measuring. So let's look at the scope. So that will be the scope, and let me crank down the input again. Enable the converter. See, that will be the DC voltage, 5 volts per division. So that is my nearly 15 volts. And now this is a 50 Hertz of input. And when I look at that, here it sounds like it's going to explode. We got some oscillations, we got all sorts of nasty stuff, and when I'm trying to drive it a little bit harder, it sounds really bad, and the idle power is 60 watts. Oy, this can't be good. But it's definitely working a little bit, and we got 230 watts of output, but I just don't dare run this too long because it sounds like trouble. No, there's no smell yet. So I was able to put in some light here from the bottom side of the PCB, and then I was able to take a picture and mirror the picture. And this way I was able to read converter 11980. So I think that is the age of this unit. And it is definitely a power supply, battery charger, a mains voltage regenerator. So this is what we called a UPS power supply. But here it's all home made for the job. That is so nice, and it is definitely super beautiful, both on the inside and on the outside. So thank you very much for watching. Please come again soon.